So next we are going to consider a circuit where we are going to find out the voltage measured by the voltmeter there. So in this case, if I am going to see, I am going to have, I want to find out what is going to be the voltage across this voltmeter there. To find out, first what I am going to do is, I am going to convert this voltage source to your current source. So when I am going to find this voltage source to your current source, your I is equal to V by R. So V is nothing but 4, R is nothing but 6. That means it is going to be 2 by 3. So 2 by 3 it is going to be there. But the direction if I see it is going to be plus. So when I am going to draw it, my current source will be like this. So your head is nothing but positive. So positive is going to be 2 by 3 amps in parallel with your resistance 6 ohms. Again I am going to have your 12 ohms to be present. Now I can see that you are going to have 6 ohms and 12 ohms are going to be in parallel. So when 6 and 12 are going to be in parallel, I can reduce that 6 and 12 to be in parallel, that is nothing but 4 ohms. So your equivalent resistance value is going to be 6 into 12 divided by 6 plus 12. That means that 72 divided by 18. So 72 divided by 18 is nothing but 4 ohms. So here it is going to be replaced as 4 ohms, 2 by 3 amps. And we are going to have your 8 volts, 12 ohms to be present there. So now what I can do is I can convert this to your voltage source. Convert it to your voltage source. When I convert it, V is equal to I into R. I is 2 by 3. So 2 by 3 into 4. So 2 by 3 into 4 is nothing but 8 by 3 volts there. So I can have this 8 by 3 volts. So this is the downward direction is downward direction here. So that means that this should be plus and this should be minus. So here I am going to have plus, this is minus your voltage source in series with your resistance 4 ohms. And now I have your 8 volts 12 ohms. Now these two what I can do is, this is plus to minus. So plus to minus means always it is going to be minus 8 by 3 whole. Plus 2 minus means minus. Minus 8 by 3. Here is going to be plus 2 minus minus 8. So if I take the LCM, it is going to be 3 8's 24. 24 is minus 32 by 3. So your voltage is going to be 32 by 3 volts. And your resistance is going to be here in series. So here in this case, this is your 4 ohms to be present there. So in the next circuit, if we see, you are going to have a 32 by 3 in series with your 4 ohms. Now I have my 12 ohm resistor. So what I will do, I will convert this voltage source to your current source. So when I convert this voltage source to your current source, it becomes 8 by 3 amps in parallel with your 4 ohms. So this 4 and 2, here in this case it is going to be parallel. So when it is going to be in parallel, I can simplify it. So 4 into 12 divided by 16. So here in this case, 3 ohms. So 3 ohms is going to be here your 8 by 3 amps and you are going to have your 2 amps there. So now if I am going to apply your KCL is nothing but your incoming current is equivalent to outgoing current. So I want to find out what is going to be the total voltage drop. So here this is your current, incoming current. If I am going to consider this to be a node, your KCL is nothing but the equivalent to outgoing currents. Incoming current to this node is going to be 2 amps. So incoming current is 2 amps. Outgoing current is from this node, the current is outgoing. So this is nothing but 8 by 3 plus your I value. So I plus 8 by 3 is equal to 2. So I is equal to 8 by 2 minus 8 by 3, that is nothing but minus 2 by 3 amps. So minus 2 by 3 amps means the drop across it will be 3 into minus 2 by 3, that is nothing but minus 2 volts. So the voltage across your voltmeter is going to be minus 2 volts there. So a source transformation is, we are going to use a source transformation technique to reduce the circuit there. So here in this case, if I see, I have 2 voltage sources to be in parallel. So if I have 2 voltage sources to be in parallel, what I can do is, I can neglect this voltage source. So this I need not consider itself. I can start considering from this part of the circuit. So my circuit is going to have the voltages 20 volts, 10 ohms, 10 amps and 10 ohms. So now to simplify this circuit, what I can do is 20 volts, 10 ohms, I can reduce it into a current source. So if I reduce it into a current source, plus sign is down here. So it is 20 by 10. So 20 by 10 is going to be your 2 amps. So 2 amps in parallel with the resistance 10 ohms. So in this case, current direction is both same. 2 plus 10 is going to be 12 amps. These two resistance are in parallel. So 10 into 10 divided by 20, that is nothing but 5. So if I convert it into a voltage source, it is going to be your, so this is plus, this is minus. So a battery voltage should be here plus, this is your minus. So 12 into 560 in series with your 5 ohm resistor there. So this is how we are going to simplify the equivalent circuit there. So here we are going to find out your V2 in the following circuit. So when I am going to find out your V2 in the following circuit, you are going to have your voltage dependent sources there. So here your 72 ohms is, I am going to convert it to your current source. So when I am going to current it into a current source, 72 by 4, that is 18 amps in parallel with your 4 ohm resistor, 6 ohm. This time again I am going to convert it to your current source, 3V2 divided by 12 ohms there. So in this case your plus sign is facing, your plus is facing downwards. So your current direction also should be downwards there. So this is 0.25. Now your all these three resistors are in parallel. 4 is parallel, 6 parallel, 12 is nothing but 2 ohms. So when it is going to be 2 ohms, your current directions are going to be your V2. Your V2 is nothing but 36 divided by your 1.5 volts. So solving for your V2 is going to be your 36 volts divided by your 1.5. That is nothing but 24. So here in this case V2. How to find out your V2? Your current, one current is in the upward direction, the other current is in the downward direction. So V is equivalent to I into R. So V is equivalent to I into R. I is nothing but your current is nothing but your 18 minus your 0.25 V2 into your resistance value is going to be 2 ohms. So if I multiply it, in this case your total voltage is going to be your V2 we want to find out. So if I am going to find out my V2 voltage, that is nothing but, here in this case simplify this equation. It is V2 is 36 by 1.5, it is 24 volts. So V2 is equivalent to V2 plus 0.25, that is 0.5 V2 is equivalent to 36. So it is going to be 1.5. So V2 is equivalent to 36 by 1.5 divided by 24, that is 24 volts. So we are going to reduce your circuit into a single voltage source in series with your resistance between the terminals A, B. So if I want to reduce it, what I can do is I can convert. Anyway, your voltage source, here I am going to have a voltage source cannot be in parallel with your resistance. So I should neglect this resistance first. Redraw the circuit. If I redraw it, it is going to be 10 volts, 2 ohms in parallel with 5 ohms and 10 amps there. So here down I am going to have a 6 ohms. So always a current source in series with your resistance means that resistance can be neglected there. So 6 amps, here 4 ohms there. So now convert the top to your current source. So 5 amps and 2 ohms there in parallel. So these two current sources are in same direction. So it is 10 plus by 15 in parallel with 10 by 7. So convert it into an equivalent voltage source. It is nothing but 15 into 10 by 7 is 150 by 7 in series with your resistance 10 by 7. Here it is going to be 24 by 24 volts and 4. So now minus to plus is going to be a plus 24 plus 150.7 is nothing but 45.43. And the resistance is going to be 5.43 ohms there. So here we are going to reduce the circuit given in the figure below into a single equivalent circuit there. So if I want to convert it into a single equivalent circuit, convert these voltage sources to your current sources, then add these two current sources, I will be getting this, convert this current source to your voltage source. If I get this, then in this case I can add this and I can have it as 14 volts and this series resistance is going to be 3 ohms. If I want to equivalent to convert this, that is 14 by 3 is going to be 4.667 in parallel with your 3 ohm resistor there. Thank you.